right, last one in this section. Let's work on a pyramid. And I think you'll have some other variety. You'll see cones and other things. But this, I hope, will give you a pretty good start. So I'm looking at a great pyramid. And I know the base of this pyramid is a perfect square, 755 by 755 feet. And I know that its height, so from the middle up, let's see, how can I show that? If that makes sense, is 410 feet. And I would like to find the volume. So I'm going to say that I want to find this volume by slicing horizontally. Again, you can slice vertically. I'm trying to look at that. It's doable. It seems a little tricky. You'll be getting trapezoids as your slices, where if I slice horizontally, what I'm getting is basically a little rectangular box. So when I take that out and look at it, it's a little rectangle. In fact, it's square. I'm saying because I know the bottom of this thing is square. So here's what my slice looks like. And actually, this isn't perfectly vertical. There's some funny slope to it, right? But the idea, again, is if our slice gets infinitely skinny, that little bit of slope to the edges doesn't matter anymore. So we're taking out some of the complicated business in this shape by making our slices really skinny. Okay, so the volume of a slice that looks like this is going to be a length times a width times a height. So let's see, easy one there. The easy one is the height. I'm going to call my height a delta y. So this becomes a delta y, which means my y is going to be a vertical variable. So we could go from bottom or top. I'm going to go ahead and go from bottom in this one because I think I've been picking the neat one in a lot of these examples. What I need to know is what are my length and width, and they should be the same. This should be a square slice with a little bit of thickness to it. And how do they relate back to y? So here's the part where we want to look at this pyramid and make this 3D picture 2D. So we're going to take a knife and set it right on the very tippy top of that pyramid, and we're going to cut straight down so that we cut these two side faces exactly in half. And when we look at what we're left with, it's just a triangle. So we cut it in half and we look straight on so that we can't see any of the remaining volume. And I know that the base of this triangle is 755 and the height of this triangle is 410. My slice is just going to look like a little strip that goes across. There's delta y. And I know that the height of my slice is y. So I need to get, I'm going to call it w. The width of the slice is a function of y. So this is another similar triangles problem. Here's my little triangle. And here's my big triangle. So the big triangle is pretty easy. We've got the 410 and the 755. The little triangle is the trickier one. It's not terribly tricky, but we don't actually have its height. So what we need to do is say, okay, if from the base up is y, then from the top down has to be 410 minus y. You know, the total height is 410. If the bottom is y, then we just need the difference between those two heights. So my similar triangle setup says that, what are we looking for? W over 410 minus y is equal to 755 over 410. And when I go back up to this formula, that means that the volume of my slice is going to be the length and the width, which are actually the same. They're both 755 over 410 and multiplied by 410 minus y. 410 minus y. Okay, so down here we would just multiply 410 minus y. Okay, so that's what we're plugging in up at the top. So that's my length and also my width, which means I need to square it. And my height is a delta y. To get the total area, I'm going to add all of those up using an integral. So I'm just going to split this up a little. I'm going to have a 755 over 410 squared times 410 minus y squared dy. And I need to start at the, where's my y? Start at the bottom, y equals 0, and stop at the top, which is a y equals 410. So this is kind of ugly. Let's see how far I can get crunching this by hand. And then I'll get my calculator ready so that we can go from there. Calculator. Okay. So I'm just going to keep this 755 over 410 squared out in front. And then I'm going to go ahead and FOIL that out. Oh, right off the bat, I don't think I feel like figuring out 410 squared on my own, so I'm going to be lazy and say that's 168,100 minus 820y squared. Zoom in and it won't be nearly so hard to fit this. Oh, that's not a y squared, that's just a y, plus y squared dy, and that needs to go from 0 to 410. And then, okay, so we still have this 755 over 410 squared. We now have 168,100 times y minus 820 over 2, which gets us back to 410 y squared plus y cubed over 3. And we want to go from 0 to 4. Not small enough, 410. Okay, so good news is when I plug in the 0, that's just going to give me 0. So I really just have to figure out what do I get, and we hope that my calculator skills are trusty. We know they're not always. 168,100 times 410 minus 410 times 410 squared, so 410 cubed, plus 410 cubed over 3. Okay, this was one of my not plan ahead on the calculator part moments, so let me see if I can check it without being too slow. Times, okay, 168,100 times 410 minus 410 to the third plus 410 to the third divided by 3. Okay, so 7,790,341,6.67. 1, 2, 3, 1, 2, 3. So 77 million. My goodness, what would I get? So here's my quick mental check to see if that seems completely ridiculous or not. So if I just made this a big old box instead of having a pyramid shape, I just said, okay, this thing is a big old box. It would have height 410, length and width 755. So I would say length 755 times width 755 times height 410. And I would get 233 million. Okay, I don't think I'm too crazy. So I would say that it should probably be less than half of that. And half of that is about 117 million. So I think it's not super crazy. Oh, and it's not feet, it's cubic feet. So we'll say on my rough check that that doesn't seem completely preposterous. Again, my calculator skills sometimes a little messy, especially when I'm using my phone. So feel free to double check, and you don't have to believe me. Thanks for watching.